Hey everybody, it's Mrs. Hofferberth. Let's talk about how we can represent chemical reactions. So really what we're asking is when a chemical reaction occurs, how can we tell someone what happened? So if this is what we see happening.
So I've got some methane gas here and I am capturing it in a bubble. And the fun thing about methane gas is, natural gas is what we usually call it, is that it's flammable. And so when I ignite this methane gas, it reacts with oxygen in the air in a very satisfying manner. And when it reacts with the oxygen in the air, the methane, which has the chemical formula CH4, reacts to form carbon dioxide gas and water vapor.
So we've got three different ways to do this. We can use words. I can tell you that in this reaction, methane gas reacted with oxygen gas to form carbon dioxide gas and water vapor. We can also represent this same process using a chemical equation, where you see here it says CH4, little parentheses G, that means it's a gas, plus 2O2, that's our oxygen as a gas, that arrow, and then CO2 gas plus 2H2O. So that's the chemical reaction way of saying what's going on. And then lastly, we could use a particle visualization where we could draw pictures to show what chemicals I started with initially and what chemicals I had at the end. We're going to take a closer look at each of these different ways of representing because you are going to need to be able to move back and forth between these representations and certainly to understand what it is they're saying. So words. We've been talking about how to name molecules for a reason because when we communicate, we like to use sentences. It's easy to say when we're talking that methane gas reacts with oxygen gas and we form carbon dioxide gas and water vapor. When you are looking at writing things in words, you need to make it clear what you started with, and these are called your reactants. And you need to make it clear what you ended with. These are called your products. And so it's important that you're able to describe in words the name for the chemical compound that you're using. However, often it's actually more convenient to work in chemical equations because this way I can just see what are my atoms, what is my molecule without having to think about, okay, how do I turn this name into a formula? It's right here for us. So I've got CH4 with a parenthesis G. This is called a state symbol. It is going to tell you whether you have a solid, a liquid, a gas, or if something is dissolved in water, which is called aqueous. So these symbols that you'll be seeing is if something is a solid, you'll see a little S in parentheses after the chemical formula. If something is a liquid, there'll be an L. I tend to use a cursive letter L because it doesn't look like a number 1. G is for gas. And in parentheses, if you see AQ, this is aqueous, which means that whatever that material is, it is dissolved in water. The left side of the equation, everything before the arrow, those are all of your reactants. And so that's what you're starting with. Then we have a reaction arrow in the middle of the equation that separates the left from the right-hand side. So that reaction arrow means this is where things are changing. We often read it as reacts to form, yields, makes, any of those things. We're saying what I've got on the left turns into the stuff on the right. The stuff on the right, these are your products. This is what the reaction makes. So again, with a chemical equation, it's easy to see what did you start with and what did you end up with. The last piece is a particle visualization. It's important to me that when you look at a chemical reaction, you understand what's changing about those molecules, what those formulas actually mean. And so the particle visualization is just back to our little bubble pictures. What did you have at the beginning? What did you have at the end? I do want to point out, and we'll talk about this next, that we have some numbers in front of some of our chemical formulas. Those are called coefficients. And these are going to tell us how many of that particular type of particle we have. And so as you notice in the equation, I have two O2s and two H2Os. So as I look down below at this particle visualization, I see that I have two O2 molecules. So O2, the subscripts tell me how many oxygens, and then the coefficient tells me how many of them. And I've got two H2Os right there. And so we can talk about things in words, we can talk about things in chemical equations, and we can also talk about things in particle visualizations. And you need to be developing fluency in going back and forth between these different ways of representing a chemical reaction.